start the video up again. And all right, so this is what I just added. I'll go over this real quick. Then we'll get into the exercise for today. Make this bigger. Okay, so there's a couple of different like online free textbooks, open source textbooks. I went through and actually took some information from both of them that talk about some things. These first few, we really didn't get into it too much. We talked a little bit about geospatial data, but it would be good information to go read, to review. File formats we did get into a bit. But then most of the lecture we spent on talking about these particular terms, the single layer operations, like and then multiple layer operations like overlay. And then this is a different book that talks about overlay and select in a separate place, but they're all good readings to go about. The next part here is this ArcGIS help for operations. So most of the tools we've talked about today, here are the links to where you get help on those tools. And it's always good to learn how to use the help when you're trying to do things. So to do that. We didn't talk about spatial join today. We're going to talk about regular joins and spatial joins next week. That'll be the table joins and spatial joins. That'll be the topic for next week. So I just didn't want to confuse anybody. So this link will take you to a site that talks about multiple layer operations, including spatial joins. Just you can read the spatial joins, but they weren't specifically the reading for this week. They'll be the reading for next week. Same with the tool reference on overlay. A spatial join is a specific type of overlay. It's a little different because it doesn't change the geometry at all. It just attaches the attributes based on a criteria. So talk about that next week. Okay, so that's the reading. Minimize that. And then I hope it wasn't Chrome updating that caused my computer to crash, because that didn't happen until after the computer came back up. Anyway, I do have a presentation in here, but I may just talk about Model Builder after I present the lab and kind of go through what's expected of the lab. I'll give you a few tips and tricks with Model Builder. I may or may not go through the actual PowerPoint, depending on the time that's available, or I may just use it as a reference. Okay, so I'm going to download the text of the lab. I'm going to open the text of the lab here. That's it. That's the lab. All right. Now we're going to have some labs that are a mix of very explicit instructions and kind of problems to solve. And this one fits in the second category. Last week you just followed through, just did the ESRI one, and it should have prepared you for a lot of what we're going to talk about. A lot of what you're going to do today, as well as what we talked about in the lecture. Okay? So what you need to do is download data from the 3 counties of your choice. Actually, it doesn't matter which ones they are. If you've already done it, great. I already did it. Okay? Then you need to open up, then you need to answer these questions. Okay? We already kind of answered those in the lecture, but I want you to re-answer those questions. And then yourselves, everybody. So the first task I want to be able to do is merge a set of data. Back up just a second. I didn't put this in there. Open up ArcGIS, just like I did, ArcGIS Pro, and save a new project. If you're using ArcMap, you can use ArcMap too, but it's a little bit different. Save a project, get started that way. Then, let's do this. I want to be able to merge a set of data of each county into a single new layer. By set of data, I mean the same equivalent layer in each county are inputs, and the output is the new merged layer. So might be saying, we already did that. We did already do that. We're going to practice it one more time. And then when you all go to actually do this lab, you actually have to make a model in Model Builder that will do the same thing. Okay? You can do it in Model Builder rather than in just pick and choose. So you get a passing grade if your model works. It's going to be a really simple model. All it's going to do is combine those 3 data sets. But you'll get full credit if it works and it's in a general form. What I mean by that, and I'll explain this, I'll show you how to do it. What I mean is that anybody should be able to select your model, but they should be able to input the layer themselves. So if they want to combine the roads, if they want to combine the lakes, if they want to combine the PLS data, whatever they want to combine, they should be able to choose the layer that they want to combine. And then your model should be able to do that. And that's some of what I had in the Model Builder presentation. So I may put that in the Model Builder presentation, or I may just show it to you. Okay. The second thing, and then what tool would I want to use to remove the boundaries that are still present after the append or merge operation? Okay, we answered that in class. Right? So you can put that in there. Experiment with the dissolve tool on one of your merged data sets. I want you to do that if you haven't already done it. I mean, if you've already done it, you honestly have already done it while I've been talking, then you're all set. But and then I want you to kind of answer this question here. What parameters would you use to keep all the input fields, but also remove all the common boundaries? Is that even possible? All right. All right. The next task that you're going to do is you're going to figure out how much public land survey is covered by a water body. So that's obviously going to involve some overlay. Your output needs to be a table that represents the percent water body in each PLS. Okay? So that is the only requirement. So it doesn't matter what it looks like, geometrically what? Doesn't matter what it looks like on the map, but it has to be a table that reports the percent water body in each PLS. So every PLS square needs to be included, even if there's no water body in the PLS. So that's kind of a clue as to whether or not union or overlay will work. Okay? Again, we'll go through that in class and do it. Your assignment is to make a model out of it as well. So we're only going to do the steps. You're going to have to build the model. You may use the inputs. Okay. You may use the inputs. You may use the merged data from the. You may use as inputs the merged data from the output of your first model. So you're going to take all of the 3-county area and you're going to determine how, for each PLS square, how much of it as a percentage is covered by water, even if it's 0. No, not covered. There's no water at all in that public land survey square. Okay, so that's what you're going to do.
A percentage for each square, or a total percentage that falls within all the squares?
No, a percentage for each square. So you'll still have a record for a row for every square, and each square will have a new attribute that represents the percent of water in that square. Yep. And your question from before applies directly to this one. So the workflow there is that we'll have the 2 layers, we'll do an intersect or a union. We'll first calculate the area for every PLS square, then we'll do an intersect or a union, and then we will calculate the intersect of the union, and then we'll calculate the percent that is that's water body. And then you'll have your answer. But you remember, there's a few things to think about. We'll probably have to do a select at some point. All right, so there'll be a little bit of logic, which will be fun. It'll be good to do the logic. Okay. All right, let's do the first one first. Let's do the merge first because we already did it. It's easy, and it's also the first one on there. To start off, I'm going to, I'm just going to get rid of everything. Got nothing left except for the dark gray canvas. And I'm going to go, I got my catalog open here, all right? Okay, so what I want to do is do the merge. For this one, we'll build most of it in Model Builder. Since we already did it, I'll build most of it in Model Builder. And then it'll allow me to talk about the Model Builder stuff that I wanted to talk about. And then all you'll have to do is to generalize a little bit. I mean, you can talk about that. But the second one, we'll just step through the processes, and you'll have to build it in Model Builder. Because I do want to talk about Model Builder. So that's how we'll handle that. All right, so the way that you get to Model Builder is it's in this analysis tool window. And you just click Model Builder. If you click Model Builder, it will create a default model for you. Your first model. It'll just create it. And, it actually puts it over under toolboxes. It put it right here. See, it says model. Now, later in the lab, I tell you to email me your model. It's this file, this TBX file that I want you to email me. And if you don't know where it is, if you hover over it, it tells you where it is. So that's where that toolbox file is on disk. So that's what you need to, not email. Email was the old way. You need to zip it up with the rest of what you're going to submit and upload it to Canvas. Upload it to Canvas. So that's where it is on disk. See, users, storage documents, RTIS. That's where it is on disk. And that's where it is. Now, what if I want to rename it? Because model's lame as a name. So if I go in here and I go to properties, I can change the name to merge MS. Oh, it doesn't like underscores. Merge MS data or merge Mississippi data. So now I'm going to merge. I'm going to call it merge Mississippi data. Now the label that shows up here can have spaces, underscores, whatever you want, but the name cannot have it. So I could actually call this merge Mississippi data. Right? We don't want to set the password. We don't want to have a password, because then I won't be able to look and see what you did. Store tool with relative pass, that's checked by default. Let's keep it checked. So it'll any data that you use will be a relative path. In other words, it won't be an absolute path to that data set. So keep that checked. It'll save any intermediate data into the project database so that when I go to load it up, I'll have it. All right, so leave that checked. All right, the parameters we'll set those later. So let's say OK. So I don't know why it didn't change over here. Have to refresh something. Huh. I mean, it doesn't really matter that it's not showing up there. Oh, save. Okay, I'm going to open up the view pane. What's that? anyway, it's that model. It's that model because when I hit properties, it shows up. I don't know why it doesn't show up here. Oh, it looks like I can change it right there. Merge Mississippi data. I don't know. I mean, I shouldn't have to change that twice. But anyway, so that's there, and now I can start operating on it. If you don't rename it, it's not as big of a deal. I'll still know. I'll still see both of them, and I'll know which one is which. All right. So with Model Builder, some of you had problems getting either access to ArcGIS Line or access to ArcGIS Pro. But with Model Builder, what you do is you just drag tools onto here, and then they can be executed. Right? So if I go back to the analysis, to the toolbox, I can start dragging tools on. I know that I'm going to need the merge tool. Okay, whoops, I didn't mean to click on it. You can actually click and drag it onto here. I'm not sure, that's not the only way to do it. So I don't know, is that the way that it had you do it in the one that you did online? Pretty much.
I wasn't listening to the first part of the question, but I think they did both.
Oh, okay. You can just drag it on. So now we've got the merge tool here, and we can set this up to run in Model Builder. And so this is really only a one tool operation. Okay, it's one tool operation. So in order to fulfill the minimum requirements for this class, you could double click on this guy for this lab, this part of this lab, and just choose any 3 data sets that you want. You could choose the highways in Lamar County, and then you choose the highways in Forest County, and then you could choose the highways in Marion County. Marion County. Highways, that's what I'm looking for. I don't know why I chose highways this time, but I did. Okay, so now I say okay, and it's ready to run. It has these 3 data sets. 1, 2. I don't know why I feel like I have to move that around. I don't. You can always like ask it to redraw. Where is it in? You right click and just nope. Model Builder. Model Builder. There you go. And then there's the auto layout. There we go. Auto layout's usually pretty good. So, all right. So now I have the model and I can run the model and it'll work. Right? If I hit validate and run, it's going to save it. Where's it going to save it? Well, it's going to save it to the directory that I'm working in, which is also fine. Oh, it's going to save it into Marion. Let's I don't know why you would put it there. I was going to put it in GDB. Yeah. No. That button, I pressed that, and I was wrong. That wasn't telling me where I was going to save. That's just the last thing that was open. It looks like the Marion County. I can tell it's going to say where it's going to save by clicking in that output data set, and I see this whole long thing. If I wanted to manually make sure that it put it there, I could hit this, and then I would go hit project, databases, and that's the database where it's going to save it. I could call it like merge output. No, you don't need to create another folder. When you create a project, it creates that. It always creates a database for that project. Yeah, so by default, if you highlight over this, what happens to you? Are you looking at it on your computer?
Yeah, I'm looking on the computer. I had mine on water body merge, but I did the highways like you were saying for example wise.
Okay. Well, by default, it should put it in this in your projects folder. If you highlight over it, is the path to the projects folder like mine is? Mine says the projects VG week 2, whatever you named your project.
I don't know.
Oh, you want me to actually look at it? It doesn't really matter where you put it as long as you understand where it's going. So,
We'll have to have a little bit more organized. Sound like I was.
yeah. So did you call your project when you opened it up? Did you just call it my project? Yeah, it's just called my project. So yeah, that's where it is.
Okay, well, whenever I get.
It'll run. Well, it won't run yet.
Don't worry about this thing. Whatever thing.
Yeah, you don't have to worry about that.
Because yeah, I was like, that's totally different. That's not the same.
Oh yeah.
So there's a water body in the highway.
It's calling it water body. So if you want to change that, you just type something.
Oh, okay, so I can't type.
Yeah, you can type.
I thought it
whatever
was like
you
it's
want.
going.
You're right. I see that it says water body.
Most of ours, when you try to save it to a file, try to go over some exercise,
Okay, you gotta actually type something like there.
okay, so I can do it. That's the right file.
Yeah. RGIS sometimes in the background is cooked up by putting spaces in file names. So I try to avoid it. Just do an underscore or panel page. Oh, it's in Forest and Lamar, you mean? That's fine. Okay, so yeah, if I want to name this something else, which I might want to do, I could just name it like, let's say high. Let's put DESIG highways, so it has the same beginning thing. I can do that, and I can put it somewhere. I can put it wherever I want, but by default, it's going to put it in your projects database, which is a fine place to put it. So I'm going to keep it there. I say OK, and now if I run this, it'll run, and it's going to create the data. It didn't add it it doesn't add it by default. So I ran this, and I can tell you can tell that it's run because in both ArcMap and ArcGIS Pro, it makes it like 3D to show you that it ran. See how it ran, and it's yes. If I hit validate again, it's not run. See how it's not 3D anymore. Okay, if I hit run, watch the shadow that appears. See the little weird shadow? That means that it ran. Yep. And if I want to actually look at that, I can right click on the highways and say add to display. So now that's the result. In the map, that's the result of what I got. What's that? Yeah, if you did highways like me, you get a bunch of squiggly lines. Or if you did railroads, you should get a bunch of squiggly lines. Not squiggly, but relatively straight lines. Depends on what layer you did. The background black? What? Sorry, what? How did I get it like that? Under
It doesn't have to look like that.
no.
It's not working.
Under map, base map, I changed it to this dark gray canvas. Yeah, I mean, I just think it looks better for But you're right. Yeah, no, it doesn't have to look like that. This is the default right here, the topographic. Yeah, so yours will look like that. Sure. It's stretching super far. Oh yeah, well you did three close counties. You did different counties, which is fine. I said you could do any three counties you want. But you're Harrison, Hancock, and Jackson are bigger this way.
So you just did two.
No, I did three counties, but I did three different counties that are shorter. Forest is really narrow.
Oh, okay.
I just did three different counties than you did. And they have a different boundary. Like
That's what I was confused on. I didn't know if you did three also or not.
Forest is right there, Lamar is right here, Marion's right there. Okay, so like I said, that fits the minimum requirements for what you need to do. But we're going to talk about a few things that you can do that are good to do in Model Builder that can help you that can help you build more complex tools, and that can allow your tools to be more portable for other people's use. The first one is to just do what we call set a model parameter. Okay? So a model parameter means that you want the user to be able to change this the next time it runs. So the easiest way to make this kind of general is to take each of these three data sets and make them a model parameter. In other words, the user can choose each of these three data sets. Yep, right-click parameter, right-click parameter, right-click parameter. Now let's say that you also want the user to be able to specify where the data saves to when it's done. You don't want the user to have to find out where the data went at the end. Well, you can make that a parameter. So I'll right-click on this, and I make that a parameter. And now the user gets to choose all three of these data, and it gets to choose where it puts it. I'm gonna go ahead and save it. Save. All right. Now, if I wanted to actually run this model, like I could press run here, but if I wanted to see how it would look if somebody else was using it, I could double click on my Mississippi merge. There's no parameters. There must be a way to save just the model. There it is, right there. Save. Okay. Now, go back to the content pane. Double click. Tool has failed to open. Validate. Wonder if it's because I renamed it. Reading tool has failed. Okay. I don't know why. Why did all of a sudden? I don't know what I did in there to make that work. I think I hit refresh here, and that was the last thing I did to make it work. All right. Did anybody else able to get to this screen where they can open it? I think you have to press save. You know that's save right there. And then go back to catalog and output here. You can move up one more. Now that looks okay. Yeah, so that's a little bit different than you got yours working, you got yours kind of working. It's not able to find that data set. No, try to see, double click right there, it doesn't work. Go back. So we need to do X this out, go back to the catalog. So what you need to do is hit save here, and go down here, right click on model, and say refresh. No, sorry, on the toolbox. This toolbox. There you go, now double click on it. And now you're this. Let's save it here. Go back here. Right click on exercise 2. Exercise 2, right click refresh. My next up. Next up here. Go to view catalog panel. You have two models somehow. So we'll X this out. Is this the one you're working on? Which one is the one? Right click on that one. Yeah, let's say that. That's what I want. Yeah, that looks good.
So you hit edit now.
In that case, go over here, right click, to edit it, right click. Go under view, model builder, hit save. Now right click on model and say, no, sorry, right click on week 2 and say refresh. Now double click on model. Yeah. That means that you've run it once and that data set already exists. If you run it again, you're going to overwrite it. That's what that means. Okay, so so these are now, you're now able to put whatever data sets you want there. So for example, if you want to select the designated highways, if you want to select the water bodies, you can go choose all the water body data sets. See if I'm going to choose all the water body data sets. Say OK. And are those all in Marion? Oh, those are all in Marion, sorry. I messed up. So you want to select one from each. Lamar, water bodies, and forest. Forest water body. Okay, now don't get those errors. See, I highlighted over an error, and it usually gives you a description of what it says. And it said duplicate data sets aren't allowed. So now, all of these are water bodies. This is where the output's going to be. So if I want that output to be different, I could change it right there. I could type in just water body. Now, I didn't change the model at all, but I can now do the merge as part of Model Builder. Run it. All right, now, so far, you might be asking, well, we just built a model that only runs one tool, so why don't we just run that one tool? And that's fair, right? I mean, this is just an example. The next tool is going to have a lot more components to it. You're going to chain them together. But before we go on to the next one, there's a few things that you can do. Yeah. How did I get back to this? I just typed in water body. I modified it, I just typed it in.
So that way we don't have to drag and drop and make everything
Yeah, well, this is a way of generalizing the model. So I don't have to double click into here, choose a different thing again, double click into here, choose a different thing. Like if this was a complex model and it had lots of inputs and an output, then these will be parameters. Now I'm going to show you a few more things that can help you generalize it a little bit more. Okay? So one thing that we can do is that by default it just names these things that are kind of cryptic, right? And besides, they no longer have anything to do. We put the water bodies in here now. So why don't we go ahead and input the, why don't we go ahead and change the name? If you right click and you say rename, you can change it to like, merge input 1. And you can call it merge input 1. And then you can rename this guy. Merge input. I'm going to use underscores actually. Input underscore 2. And then I'll do the same. I'm going to rename that first one with underscores again. Merge input 3. And then I'm going to rename this guy. I'm going to rename this guy output. Output data set. All right, now it doesn't instantly show up over here. I have to go back to Model Builder. I have to click Save. And then I have to, I'm going to close this up, refresh. Seems like a lot to do. And now I open this guy. And now I've got the merge input 1, merge input 2, merge input 3. They're called something that's a little more descriptive. And I've got my output data set listed as output data set rather than some cryptic file name that was for a different data set entirely. All right? Now, I think that for anybody that completed it, did you guys do that where you renamed the inputs and the outputs, you renamed things? So you did that, all right? Now, you didn't do a few of these other things. I think next week I will show this iterations one because it would be cool. But I think this week. Let's see if I can collapse this down a little bit. Yeah. Okay. Yeah, we can do this. All right. Now, if you guys have noticed, the files all have the same beginning, but they don't have the same ending, right? They all have the same beginning, but they don't have the same ending. And the ending part is kind of what determines what county it is. The beginning part determines where it is, or what it is, or tells you what it is. So, what I want to do is talk about this concept of variable substitution in models. So this is it's a programming language, but it's a graphical programming language. But there are still ways to do things that a programming language would do. And one of those things is to have variables and allow those variables to change and allow you to calculate new variables from those variables. So what we could do is instead of asking the user to provide 3 different shapefiles, instead of asking the user to provide 3 different shapefiles, we could ask them to provide just this information. And by the way, this stuff I'm talking about now is just extra. So this would get you this would make it general enough for so this designated highways, what if we just provided that? And then the user, then we could run the model and the program would fill in all the other information. Okay? We can do that, right? To do that, we need to create a new variable. And that's this little bubble right here. A bubble allows us to put a variable into the model that can change, or that we can store a value in it. So I'm going to take the variable and I'm going to make it a string, and it's just going to be I'm just going to leave it like that. Say okay. So now I've got my string here out here. Got my string. I'm going to rename that. I'm going to rename that layer underscore name. So I've got my new layer. I've got the name of the layer that I want to input. By default, let's just call that. Let's just put a value in there of just this word, DESING highways. Go in there. Now we're going to call that. So now this variable is storing just this word. It's storing just that value inside of that bubble. Okay? And I want to use that value to be the input to these other values. Okay? So the way I can do that is I double click in here, and the part that's just that word, I need to, oh wait, yeah. Actually I think I need to run something else, but let me see if this will work. Percent layer underscore name percent. Let me see if this works, because I think I actually need to run the other tool. Which one was that, by the way? That was merge input 1. Actually, I think that is going to work just like that. So what we're going to do here okay, let's see. 73. Yeah, see, it came out as designated highway 73. Okay? So it evaluated that this string with the percent, the name of the variable percent, it knows to replace the word percent layer name percent. It goes and it tries to find layer name, and it shows that in there and uses that as a new thing to put there. It's a substitution for that value. Now, next week, I'll tell you the next step there. And the next step is to use this calculate values tool, and that allows you to put in a bunch of logic. So you can create all sorts of different values. Okay? You can even program in the logic that said, if it's Marion County, add 73. If it's Lamar County, add 80, whatever. Okay? But for now, this is a simple way to do it. So I've got my merge input 1, and if I do that to each one of these, so each one of these I'm going to take the DSING and say percent layer underscore name percent. Has to be, I'm pretty sure it's case sensitive. And then do that one more, whoops, not there, double click here, and say percent layer underscore name percent, and I got a little S in there when I shouldn't. There we go. All right. Now the other thing I'm going to do is make it so that these are not parameters anymore. Don't want those to be parameters. Okay. And I don't even want this to be a parameter because I'm going to go in here and I'm going to change the value here to just be percent layer underscore name percent. So what I'm doing here is saying, whatever you put here is going to be the name of the output data set, and I'm going to use that same thing to grab the other data sets that I need and put them in there. Yeah. So I'm only replacing the word right here, this part, the DESIG or whatever data set you're using. Percent layer name percent is a substitution for those words in this case. Yes. Percent layer underscore name percent. It's whatever is right here with a percent before and after it. Now I am going to make this a parameter. Okay, so now the user, all they have to do is know which layer they want to merge, type it in, press go, and it merges it for them. So I can hit validate here. I'm also going to hit save. And now, if I close this up and I refresh this, I look at the model, all it does is ask for the layer name. Right? That's all it does. And then when I run it, it executes it, and it creates that output. And so now if I want to run a different layer, let's go back and look at on the map. I'm going to add a layer in, and projects. You could put underscore 73 if you wanted to, but I was just saving it as percent layer name percent. That's it. So folders, week 2. Let's look here. Okay, so we've got this one that's called CO. Okay, it's just the whole county. But if I change this to just CO and I run it, it's going to merge those CO layers. It successfully completed it. It put it there in the CO data set. So let's go. I should have made it so that added that data automatically. You can go under view. Where's the results nowadays? Oh, here. Nope. I don't know where the result is. Let's just add it manually. So let's put that data in our database that we're working on. Under databases, there should be a file that's just called CO now. Where'd it go? I don't see it. Let's go back to our model real quick, and I'm going to edit it. I'm going to make this add it to the, oh, it's already added to display. Okay, it's working. It's just not adding it to the display unless I say to add it to the display. So I'm going to go back to Model Builder, save it, and then refresh. So now when I try to run it, let's see if I try to run it with some other layer. You remember off the top of their head what another layer is? View, catalog pane, pop PL, that's pop underscore PL, right? Pop underscore PL. That's it. It doesn't seem to be running from here. I'm not exactly sure why, but we'll build on this next week. So for this, for right now, just make sure you can get this to work. Not necessarily the layer name, just the 3 inputs merge, and you get an output data set. And it's fine if you let them choose the inputs individually. Okay? But this is a good thing. I'm just not exactly sure why it's not running when I try to run it as a model. It'll run just fine. Like if I go back into here and I go into here and say pop underscore PL and say okay, and then rerun it, the output data set will look correct. So now those are the populated areas. If I look on disk, it is stored in that data set and it's called pop PL. Okay? So it's just a mystery to me why it's not running over here. Probably something that I'm not familiar with as yet in ArcGIS Pro, which I should. It's running from the toolbox just fine. I just couldn't, I wouldn't be able to share this because if somebody tried to run it, they'd be like, what's going on? But if they ran it from the tool, they would see it. Okay. I'm going to go ahead and save this. So the reason why I want to move on is because the second tool is a little bit, the second tool that we're going to build is a little bit more complicated. I'm going to close all these down. All right. So the second tool that we're going to build is going to figure out the amount of each public land survey that is than is a water body. All right. So let's think about this process. I'm going to add in the data that's under map, add data. I'm going to add in both of those layers. I think I'm going to get rid of the other layers too. So I'm going to add in, it doesn't really matter which county you choose. Let's just do one county for now. So that's going to be the input data. I'll just do Lamar County. And I want the water bodies and the PLS. I'm going to remove everything that's not those two. I guess I could just create another map now. You can do that in ARC. In GHY, I mean in this project, that probably would be a better solution. But in ARC Pro, you just say insert new map, and you can have as many maps now as you want. All right, I'm going to put the water bodies on top of the public land survey and change the water bodies to blue. I just double clicked on it. I'm going to change the PLSs to like, I think I'm going to, these are the pre-canned ones. I'm going to change the color to no color and the outline color to red. No, you don't have to. I'm just symbolizing. That's actually not very good. Maybe water bodies and the PLS data. I'll go to light gray canvas. Maybe it'll show up better. That's a little bit better. All right, no, you don't have to make it look like it. What I'm going to do is find out how much of each of these squares has water in it. That's a task that we're going to do. And so let's think about the process. Adam was right that the first thing to really do is to figure out what the current area is, because it will change once we do the overlay. So the first thing that we want to do is change that. Okay? So all right. So the first tool that we want to run in order to add a new field and calculate the area into it is the add field tool. We want to run add field. So I'm going to go back here and just search for add field. We did kind of already do this one too, but not very much. So we're going to add a field to the PLS. And the field name is going to be called total area, let's say. I like that because it's going to be the total area of the entire data set. I mean, the entire public land survey square. The total area of the public land survey area. How big is it? Okay. And then we want to make it what? Remember from before? Double, yep. Make it a double. All right, and we're going to run that guy. That's what the add field should look like. It's got the public land survey. The field name is total_area. Now, one thing I forgot to mention, there's lots of differences between different data formats. A shapefile will only allow 13 characters as a field name. File geodata databases, I think it's 255 for field names. They don't allow spaces, but they do allow 255 characters for a field name. So you can have much longer field names in a file geo database. Right now, what format is the PLS in? It's the one I just downloaded. I haven't changed it yet. It's a shapefile, so we can't have it over 13 characters. It's not total areas. It's under 13 characters, but ArcGIS used to fail. I'm pretty sure now it'll warn you. Okay, it's still going to fail. Oh, and it's 10, not 13. Sorry. 13 must be the length of a file name for something else. Anyway, total area. I'm going to hit run, and it's going to run that. So you need to add field when you do your model builder model. Add field will be the first one. Okay. And then after you do add field, you're going to run calculate field. You're going to calculate the field just like we did before. You want to calculate the area. Now, what units do we want to use for calculating the area? Does it really matter? Somebody come up with a reason why it would or wouldn't matter. Be consistent with water bodies. Well, the workflow here is going to be that we take the data and we somehow overlay them to find out how much is water. And so we're going to have to calculate the value again after the overlay for how much is water. So it does matter what the water bodies are in because of the overlay, but we already know they're the same projection. Right? I'm saying, does it matter if we use hectares, meters, feet, whatever? We're interested in a percentage in the end, right? So one of the arguments is it doesn't matter. Okay? We could use whatever units we want as long as we each time we do the calculation, we use the same units. That's one argument, right? However, and that would work just fine. However, we can save ourselves one calculation. We can save ourselves one calculation because when we do the overlay, if we save the output as a file geodatabase rather than a shapefile, what happens? It calculates it for us, and what units does it use? It uses the units that are native to the file itself, which in this case is square meters. So if we use square meters right now to calculate this total area, after we do the overlay, it's going to recalculate that value. It's going to provide a field that we know is going to be called shape_area because that's the way ArcGIS works. And we'll already have the before and the after values calculated. Does that make sense? So we'll be fine. I mean, so that might save us some time. We don't have to calculate it twice. We only have to calculate it once. So let's go ahead and do that. So our input table is going to be this PLS. And our field name is going to be the field name we're going to put the data into. So it's going to be total area. And then the total area is going to equal what? Well, this is where we have to get that formula. I'll just tell you, it's shape.area. And by the way, if we don't put the units, it will use the default units. We could type in square meters here, but it'll use the units we want it to use if we just write shape area. Exclamation point, shape capitalized, dot area, exclamation point. And that should work. Sometimes I have to go to the help to make sure, but I think that's going to work. I'm going to run it. Completed successfully, yep. And it has all of these values for the total area. We've got the column that represents total area, and we could see if these values kind of make sense. Okay, they should be roughly the same because we're dealing with big data. And they are roughly the same. They're similar. They all start with 2.6 or 2.5. Those are reasonable numbers for square meters for these pretty large areas. I'll leave this up for a second. That should be what you need to do. Exclamation point shape dot area. Alternatively, you have an @ sign with the units, but we want to use the default units. Let's see, let's sort these. Oh, I got some that came out really low too. They must be like just partially in the county. Because look, I'm highlighting one of these, and I don't even see it. That's it right there. Wow, that's actually some like error in the data. Look at that. I mean, there's not. I'm not gonna worry about it. But that's actually error. That's actually an error in the data. So there's a little green polygon right here for some dumb reason. And that's always something that's good to check. Now what about these guys? These are probably at the edge of a county somewhere. Because they're actually, yeah, so that's the very edge, oops, that's the very edge of the county. This one is just barely, like a little teeny piece of it is in Lamar County. But we might want to do something where we just remove every value under a certain one, but it doesn't really matter for what we're doing right now. But if we were doing this in real life, I may want to just remove everything that is, under. Let's see what happens if I removed everything under 6,000. No, you can't do that. Used to be able to do that. I could select them. Okay, so those are all the ones that are under 6,000. Yeah, those definitely would just look like errors. So I could do something like that. I just sorted. I sorted this ascending and I selected all the top ones. If I wanted to do that faster, I could have gone into select by attributes and then said total, new selection, that's fine. And then said total area is less than 6000. Run that, and then I would get that. See, now I have the same thing selected. But I did it manually by sorting that total area column. I sorted on this column right here, and then just select. If you select right, if you touch right here, it selects it manually. And then I had to sort total area. See, now I'm just going, and I see, oh, that's the last one that's under 6,000. Just did it manually. All right, well, I'm not going to worry about this. Make sure that you clear your selection if any of you have selected it. So for today, I'm not going to worry about those weird PLS things. I think it's this FID STPLS. You might be able to merge on just that one. STLPLS. Yeah, one of those two. STPLS. You could dissolve on one of those just for fun. But we're kind of running out of time today, so we are talking about different ways to overcome this issue of these really small slivers. One of them would be to see if we could dissolve on one of these. Maybe they're just accidents. One would be to just get rid of them by selecting them out. But in any case, None of that matters now. So we ran two tools so far. We ran add field and we ran calculate field. For calculate field, we just calculated the shape area. Okay. So in order to finish this up, we need to do an intersect, and then or intersect or a union. I actually think we need to do a union. And I actually think there's more than one way to do it, but we at least need a union because we need to know we need to know even the 0 ones. So at the end, we should have just as many records as we had before. Okay. So I think we need to do a union, and the union will tell us how much is water body, and then we'll need to figure out the percent water body from that value. Okay, so let's do our union. So we're going to union the water bodies and the PLS, and we're going to make sure that we save it into the geodatabase project. See that? The order of operations for union actually doesn't matter. So these values, they can be flipped, yeah. And the order of operations for intersect doesn't matter either, because in the intersect, everything needs to be intersected. Now, if you did intersect operations serially, like if you said, I'm going to intersect A with B and then B with C, that still wouldn't matter. Because you're still only going to get the areas where they all overlap. So, yeah, it's the order of operations for both union and intersect. That's a great thing to bring up, but it doesn't matter because you're only going to get the areas where they either all exist or you're going to get the sum of all of them. So we've got those down, and we're going to save that. Let's just save it. Let's make sure we save it into the project database. And we've got a bunch of just stuff that I made while I was doing the lecture. But what's important here is this is the union. I'm just going to put water _ PLS. So I'm going to call it that. You can call it whatever you want, but that's the name, and that's where it's stored. Now I've highlighted it over. And again, it doesn't matter where you store it. Just remember where you store it. And in this case, we want to save a step by making it calculate the shape area itself, so we want to store it in a file geodatabase. That's as good a place as any to put it. All right, yeah, we want to join all the attributes, and we're all set. So we're going to hit run, and the output's going to show up here. It's the union of the water and the PLS. What? That is not what it should look like. The attribute table looks reasonable. Oh, yeah. Thank you. Awesome. It's not what? Well, yeah, so outline color, well, the outline width is 0, so if I change this to 1, then I should get, yeah, okay. I'm gonna choose a different one though. Under gallery, I'm gonna choose, I don't know, something with a boundary though. Let's just do this, I'll just do this, yellow with a really small boundary. Yellow is pretty weird looking. It is a light yellow with a boundary. Okay, I like that better. All right. So I'm going to go back and clear this selection here. So yeah, so the reason that it didn't look right when I first did it was because the boundaries weren't showing up by default. Okay. ArcGIS is much more random in terms of what ArcGIS map is much more random in terms of the default that it chooses. This one seems to choose one of the layers you already have and make it so anyway. We've got all those, and see how the boundaries are burned in, right? And if we go down here, we have 2,436 polygons where we used to have 465, 568. Okay. So we've got a union. Okay. So what's the next step? We need to find out what the wet or it actually doesn't matter. Does it matter if we find out what the wet area is or the dry area is? We can figure out either one, right? But we've got, in some cases, we've got multiple circles, right? Multiple circles here. And each of those circles, all of these circles, 1, 2, 3, 4, 5, 6 features where we used to have one. And in reality, we need to have 2 features there. We need to have the circles, and we need to have this area outside the circle. Or the water bodies and the area outside of the water bodies. So what can we do to get it so that we remove or we combine this one, this one, this one, and this one, and this one? We combine those into one, and we combine this into one. So we only have, basically what we want to have is just 2 polygons per PLS. Dissolve, that's right. So I guess today's answer when I ask it is dissolve. That seems like. But yeah, dissolve. And dissolve typically is used to erase common boundaries, but it doesn't have to be. In other words, if we check that create multi-part features, it will dissolve even if they don't share a common boundary, only if they share common attributes. So what we need to do is dissolve based on both PLS and what? The water body. So if it's a water body, dissolve it, and if it's in the same PLS. So we need water bodies and PLSs dissolved. So let's do that. Now, alternatively, we could have done the dissolve first before we even did the overlay. Right? We could have done that. So, and I don't know which one would be faster computationally, because we would have one big feature of all of the water bodies dissolved and do the overlay. That would take a little while, but it's also going to take a little while to do this dissolve. And so, remember before I was talking about computation time, do selects and clips before you do overlays if possible, but dissolves and overlays are both pretty computationally intensive, so it probably doesn't matter too much. Okay, maybe if one just failed on the computer you were working on, you could fix it. But all right, so we're going to do. You could experiment with doing one before the other. So we're going to take this Union Water PLS and put it over there, and it's fine. Union Water PLS dissolve is an okay name, I think. And we're going to dissolve based on these field names are kind of cryptic. But we're going to base it on the PLS ID, and we're going to base it on whether or not it's in a water body. Do we have a field like that? let's see, because let's look at the water bodies. We might not even have a field like that. Do we have a field here that is always the same, regardless, for every single record? The type? F-type? Is it the same on every single one? Let's, just to make sure, we could select by attributes and see if the F-type, you say? F-type is equal to 390, right? Run it. 1726 of 1742. That's almost all of them, right? What about that F code? Did you already look and see if that one works? We're trying to find out an attribute that's the same in all of them. F code is equal to 39. It's not? All right. Okay. Well, actually, yeah, that one probably will. That one stands for FID, that's the standard county number, so that's, or maybe it's not standard. Anyway, did that one work? What's that? There's no changes? Okay. So, so we can use that field. Okay, we're getting really close to being done here, and we're getting really close to when I should be letting you out, but oops. So let's go back to that dissolve. Did I lose it maybe? And we're gonna base it on the Union Water PLS. Yeah, we're gonna base it on the one I said before, which was the PLS ID, and we're going to base it on, what did you say it was? The one that was the same? What could we have done to make sure that there was a field that that we could dissolve with? We could have added one and created a field called isWaterBody or something, and put a 1 in every single one. And then, once we did the union, we would have that. The other option is we could have just done the dissolve. If we did the dissolve beforehand, and they were all one feature anyway, then any feature, any field would work just fine. So that might have been a better thing to do, at least in this case. So when you're building your model, if you want to do the dissolve first, then you won't have to do this exercise where we dissolve afterwards and we use this kind of done field. Okay, so the answer is to do the dissolve first. That's what I would do when I'm actually building a model. Okay, but we don't. It doesn't matter for now. I would just do the dissolve first, and if you did the dissolve first before you did the overlay, then you would only get those two values to start off. So this is taking a little while. Not too long, but it should take a few minutes. All right, let's look at this attribute table. And now, we might have a few exceptions. But 568 plus 568 is what? Okay, no. I was thinking that we would have double 568 because we'd have a wet and a dry area for each PLS. Why don't we have double? We have a little bit under double. Some of them don't have any water. Exactly. Okay? And that's fine. we're fine with some of them not having any water. However, the fact that some of them don't have any water is important. So we actually want to examine the ones that don't have water to get the answer that we want. We want to know how much area is covered by water, or what the percentage of area is covered by water. But to do that, we're actually going to build that equation off of the areas that don't have water. Because if we did the other way, we wouldn't know. Okay? Just to test that, let's go select by attributes for this dissolve one and say that we want the, so this means that it has water, right? So if we run that, we get 407, and if we edit that, and if it's 0, that means it does have water, or doesn't have, that means it doesn't have water. The other one means it does have water. So now there's 548. 548, that number is the same. Well, it's not the same. It's off by 20. I'm thinking it's because of all those little slivers. Okay. But that's fine. It's pretty close. So now we've got the ones that are selected are the non-watered ones. Okay. Zoom to. All right, so that's all the non-watered areas. So what we want to do is we want to calculate out the values, the percentage of water. How can we do that? So we take the total area and we divide it by the shape area, and we'll have the answer that we want. The only problem is, in the dissolve, the total area got ruined. So I really led you down the wrong path here. All we needed to do, though, was we needed to do the dissolve of the water bodies first. So it's not gonna work. Let's just go back to the water bodies and dissolve them all first. So go back, open up dissolve. I'm just going back to, I have the PLS and the water body. I still have the PLS data where I calculated the extra field, the total area. So yeah, I removed the 2 data sets that I already created. Yes, the dissolve and the union I took off. Yep. So the only 2 data sets that are in here are the water body and the PLS. We've already calculated total area on the PLS. And so there would be a few, there's no way to proceed from where we are. There would be a few different ways to proceed that would still allow us not to have to redo the union, but it's better to just redo the union at this point, to do it right, to show you how to do it right. So we need to, what dissolve field should we choose? We're going to dissolve all the water bodies into one field. Doesn't really matter. So don't choose any dissolve fields, and they'll all be 1. And remember to leave create multi-part features selected. All right. Now we can do the union, and it'll be all set. Let's open up the attribute table here. This field right here, this object ID field, I'm pretty sure I'll move over. But in case we wanted to be sure, we could add a new field here and just call it is wet or something. Let's just do the union and see if it's there. Union. I'm going to union the PLS data with the dissolved water bodies. Yep, select all attributes. It's fine to call this PLS 73 union. Fine. I'm going to run that. So now once that's done, I'm going to change the symbology back to that something. What did I choose before? Oh, like light yellow? Okay. Now I'm going to open up the attribute table. All right. So there's this FID, NHL water body, NHD water body dissolve. And so there's a bunch of values in there, and those values are either 1 or they're -1. 1 meaning that in this data set, there was a value of 1 for the object ID. -1 meaning that it didn't exist. So for this field right here, -1 is telling us that it was not in the wet field. 1 is telling us it is in the wet. It is in the wet area. Okay? So that field will tell us what we need to do. And so all we need to do now, we've got the total area and the shape area, and we can come up with a new value. How do we calculate that output? Should we put it in a new field? Let's put it in a new field. This is the last, second to last step. We need to add a field. We're going to use this data set. The field name is going to be percent. I'll just say percent area. We want it to be a double again. And we'll say run. And then we need to calculate a value into that field. And this time, it's not going to be a super fancy. What field do you want to calculate it into? It's the one we just created, the percent area. So how do we calculate the percent? Which one's going to be bigger, this total area or the shape area? Yeah, the total area. So the percent area is going to be the shape area divided by the total area. Okay? This is on the denominator, this is on the numerator. Then we need to multiply it by 100 to get a percent rather than just a proportion. So all we need to do is say shape area divided by total area times 100. Like that. And I always get paranoid about order of operations, so I'm going to put parentheses around that. Okay. So I have parentheses, exclamation point, shape underscore area, exclamation point, divided by, which is slash, exclamation point, total underscore area, exclamation point, parentheses, asterisk, 100. So I'm multiplying that by 100. And if I say OK, if I run this, I'll get these percentages. All right, now it looks like because of rounding errors, I got 1 above 100. So maybe I'd want to chop off a few decimal places, at least 1 above 100. Okay. Now, how do I get rid of those values that are the ones I don't want? Because I have, remember this field tells me whether or not it is a polygon that represents the wet part or a polygon that represents the dry part. So in this case, I get a -1, meaning that it's the part that represents the dry part, the non-water body. So in this case, this particular PLS is 100% wet. See that? I mean 100% dry. Sorry. That's what I meant. See, there's no water in any of that polygon. But let's look at. I'm curious to know what this one is. That one says the percent is 70. And inside it says that the percent is 29.9. So that makes sense. We've got both, they add up to 100. This polygon and this polygon with all these spots. So I want just this polygon. I don't want any of these polygons in my data set. The wet ones. The wet ones all have a value of 1. See that? They all have a value of 1, and the dry areas all have a value of -1. So what tool that we talked about today could I use to extract out just the dry areas? And what would I do with that tool? What's that? I don't need to dissolve. This is just a table operation, right? I'm just removing anything that's 1. If this field equals 1, get rid of it. Or another way to say that is, if this field equals -1, keep it and put it into a new data set. What tool did that today? No. This is probably the very first one we talked about. It's just a plain table operation. No, it's select. We're going to select out and create a new data set. Okay? We're just going to take everything that equals -1 and keep it. So now if I go like this, bam, go, tools, select, and then I run it. It's going to be on this data set. No, PLS union, the union data set. And I'm just going to add a clause that says, if this big old field name right here is equal to -1, add. Make sure that you take the selection off. Otherwise, it uses the selection. And then run this. And I'm going to get my final output. What did I? It's equal to -1. Yeah, okay. I have to turn everything else off. So now you see that only those dry areas got kept. So now we have our answer. If we open up this attribute table, it only has 564 records. Again, I think that's because of those few little slivers. It's not exactly. And we have the percent area that's, in this case, we have the percent area that is not covered by water. So it's, to get the area covered by water, we could just do 1 minus, or we could have done that back in the calculation. But in any case, we have our answer. So, yeah. So which one? Yeah. Okay. So I'm going to, yeah, I'll leave it right there while I say this. So I know we're about 5 minutes past, well, actually, we've been here for 11:30, 12:30, 1:30, 2:30, 3:30, yeah. A little bit over, but we had a break, a longer break today. But let's review what we had to do to get here. So tell me if I'm wrong. Okay, the first thing we did was add a field to the PLS data. Then we calculated the total area of each PLS area using the calculate field tool. That's what we did first and second. The third thing we did, this is where we started going bad, so I'm just going to go from where we should say the third thing. The third thing is we dissolved the lakes, the water bodies, into a single field. We didn't put anything for a dissolved field. We just dissolved all of the water body features into one feature. That's the third thing that we did. Okay? The fourth thing that we did was we unioned the lakes, the water bodies, the dissolved water bodies with the with the PLS data, the one that had the total area calculated. That's the fourth thing we did. Once we had that union, we calculated a new field, and we calculated the percent area. That's the fifth thing we did. Calculated the percent area into that field. So I guess that's the fifth and the sixth thing, adding the field, calculating values into that field. And then finally, the last thing that we did was we selected out only those records that we wanted, which in this case were the dry areas, the areas that weren't underwater. Okay? And so we can ask all sorts of questions. We can say, we could sort this, and we can find out which PLS has the most water in it as a percent of the area. So it's that one right there. So this one has the most water in it as a percent by area. That dam actually failed a few years ago, right? That dam, or is it a different dam? Anyway, but that's the answer. It's that one. And it has about 42% of that PLS about 58% is underwater because it's 1 minus that value. All right, so those are the steps. Now they're recorded, and I'm pretty sure the recording is going to work. So that you need to go into Model Builder and chain those tools together and build your own model. And don't worry about getting it to run from this area. Just run it in Model Builder. Okay, and I'll figure out why it didn't run as well from the other. But make sure you save it and then send that to me. Yeah. Sure. Okay, but I'll come over there right now. I'm just going to stop the video, and that's it for today. So if you want to start working on it, you want my help, or anything, I'll be around. But that's the end of the formal talking for today, and I'll answer your question.